This training video will demonstrate to the installer how to properly CAD weld or exothermically weld a signal bond to the rail. The exothermic reaction requires no outside source of heat or power. The CAD weld process was developed in 1938 by Dr. Charles Cadwell to weld copper alloy signal bonds to the rail. Recommended practices for exothermically welding bonds to the rail are listed in the manuals of the American Association of Railroads and the American Railway Engineers and Maintenance of Way Association. CAD weld and all products produced by Aeroco are manufactured in our ISO 9001 and UL registered facilities.
The item that I'm holding in my hand is a CAD weld welder, designed for welding a bond wire to the head of the rail. Hi, my name is Jim Huntley, and during the next several minutes, I will demonstrate the proper way to make a connection to the rail and show you some of our other products we provide to the railway industry. No matter what size wire or cable you are connecting to the rail, we recommend that it be either welded to the web of the rail on the neutral axis or to the head of the rail within the confines of the splice plate. We provide an engineered system for making connections to the rail. The system consists of a welder, which includes molds made from graphite, and a clamping frame for securing the welder to the rail. Weld material designed specifically for this application, a bond wire or cable with the end formed to fit into the welder and flat against the surface of the rail. Here's how easy it is to weld. Position the welder to the head of the rail. Set the height adjustment screws, then clamp snug to the rail, but not too tight. Slide the disc into the mold. Dump in the proper weld material. Close the lid and ignite the starting material. The weld is complete in a matter of seconds. Here you can see the finished bond connection. We've cross-sectioned the connection to show the quality of the weld. Welding to the neutral axis or web of the rail is very similar. The welder is slightly different, but the process remains the same. As you can see, the web welder is designed to fit over the ball of the rail and down onto the web. In both applications, clean and dry surfaces, molds, and bonds are necessary. Both for worker safety and successful product installation, the rail should be ground to a bright, clean metal. The rail and molds should be free from any grease, oil, water, or other contaminants. When you follow these simple procedures, you are assured a successful permanent connection every time.
The CAD weld rail bonding process requires a pre-engineered system of bonds, molds, clamps, and properly sized weld metal. Here you can see the system used for installing a typical 3/16 tab type web signal bond to the rail. The bond kit contains a pair of replacement molds, weld metal, and the bonds. To properly prepare the rail for welding, use an Aeroco grinder and grinding wheel. A welder frame is required to clamp the molds and properly position the bond on the rail. The weld metal is principally composed of granular copper oxide and aluminum alloy. Through the exothermic process, a chemical reaction of the copper oxide by the aluminum produces molten copper alloy and aluminum oxide slag. The slag floats to the surface before the steel disc melts, allowing molten copper alloy to flow into the weld cavity and complete the weld. The tube containing the weld metal is divided into two parts: copper oxide granules and the starting material. Copper oxide granules, which make up the exothermic welding material, are the bulk of the material in the tube. The tubes are sized in gram units, and the mold and weld metal relationship is pre-engineered to produce a desired result for each specific application. The ignition temperature of the weld metal is 1800 degrees Fahrenheit, and the reaction temperature is in excess of 4000 degrees Fahrenheit. The starting material contains the same elements as the weld metal, only in a finer particle size. It has a lower ignition temperature of 850 degrees Fahrenheit. The starting material is compacted in the bottom of the tube, keeping it separate from the weld metal. For this reason, the tubes must be stored and shipped in an upright position. The weld metal tube is packaged with the appropriate steel disc. The size of the weld metal tube is indicated on the cap and bottom of the tube. For example, here is a 25-gram weld metal tube. The yellow cap identifies weld metal that is specifically engineered for rail steel. The graphite mold is custom machined for each specific application. The areas shown in this cutaway of the mold are as follows. The crucible is the cup section of the mold. It retains the weld metal until the starting material is ignited, at which time the weld metal becomes molten copper alloy. The disc seat holds the steel disc in position and retains the weld metal in the crucible section of the mold until the weld metal becomes molten. The disc serves as a valve that controls the drop of the molten copper alloy. The molten copper alloy will melt the steel disc after the slag floats to the surface, allowing the molten material to pour onto the parts to be welded. The tap hole is located directly under the crucible and is the entry to the runner. The runner directs the molten weld metal to the weld cavity. The weld cavity is the location where the exothermic welding process occurs. This process makes a homogeneous weld of the bond terminal to the rail. To ensure proper usage, a mold tag is attached to each mold. Imprinted on the mold tag is the mold part number, instruction print number or IP, a description of the connection such as the type of bond and type of rail and the proper size weld metal required. As you can see from this array of bonds, there are many types engineered for specific applications, from the standard web signal bonds to more complex bonds for special needs. The bonds are composed of a formed sleeve terminal and Erico bond strand cable, which are available in 3/16 or 5/16 diameters. The terminals are factory made or can be made in the field by using a hammer die. Molds are designed to fit the factory-made bonds or the field-made bonds. Sleeves, Erico bond strand cable, and the hammer die can be purchased when it is necessary to use field-made bonds. The terminals are formed when the Erico cable is inserted into the sleeve and the combination is placed into the concave area of the hammer die. Then, close the anvil of the die and strike the die with a hammer. Erico compression sleeves can be installed on the opposite end of a track connector. A variety of Erico bond strand cables can be supplied, bare or insulated, to fit your specific application.